Meni është Rajne Mutsch, më sigurisht shumica keni qenë në punët e ti, është industrial designer. As Rajneli se ka ditë që ka një farë benchi para HQ-s të Raiffeisenit, nëse shkoni në ndërtesën e re, është realisht në sajt kafit, nëse shkoni që ulësja e parë, që është të keni edhe të Raiffeisenit. Telling them you have a bench here. So, në është në dizajneri industrial I parë që ka ardhur në KAF, në festival me ligjeru, që ka qenë në derë neve se për në me ka bo disa nga punime ma dalu në botë, ka bo dizajnin e radio orës, ka bo dizajnin e që ulseve që janë benches dhe shumë dizajne tjera që me siguri keni me pa dhe kam rastis me pa në revistat të interierit dhe të arkitekturës. Pa da është muzgar shumë, kisha pas që të mëftu në Rajnerë me anismë që please Rajnerë.
Thank you, Bekim. First of all, I want to thank you for the invitation to this fantastic festival, where, as you might have recognized, we just have finished our very successful workshop for the last 2 days, and which really made me happy to see how what is possible to develop in 2 days. As Bekim might have already mentioned, I didn't understand it, but I guess you've said I'm not an architect. I have an office in Vienna for industrial design, and our main focus is actually furniture lighting design, but we also do now watches and product design, and we are kind of an interdisciplinary design office. And what I'm going to show you is an insight of my products, what we have already done, and some really details normally you don't see in the high glossy design magazines, because design is always not about winning and making the nice high glossy product shots, but also about failure, testing. Really, sometimes it doesn't work out at all. It's always a new and very interesting process. And so I've put some products together. Please don't wonder, there are a couple of Rainer Mutsch logos onto the sheets. But it might even be an advantage, because then you don't forget that after every sheet who is talking to you. So let's start with this one. This was a very interesting project for me, because this was my first serial product at all. It was a competition hosted by an Austrian company called Eternit. And Eternit, since there, is a material which is very important for my general work. So Eternit you have to consider as kind of a material used for cladding, roofing and facades. So it's a very thin kind of concrete which is armored with cellulose fiber, and it actually was invented end of the 19th century. So it's a very old material. It was actually, the contractor was the Emperor of Austria, so you can imagine this is really long time ago. And since I was the lucky winner of this first competition from Eternit, which was about flower planters, but the task here was to use straight panels, and I developed a modular flower planter system. This was in 2007, I think. But the interesting thing was, does everyone understand me well? Yeah. Okay. The interesting thing about this was, and this was also a very important moment for me, is the first time I visited the actual manufacturing facilities. And what I've seen there was the actual Eternit machine, which you can imagine as a huge paper machine. So there's a huge wheel on it, and there was literally the logo of the Emperor stamped onto it. So the machine was running since the end of the 19th century, non-stop, 360 days per year, and still manufacturing this material. So I was really so stunned by that, that I thought to use this very special ability of this material. And this is that when it comes out of the machine, it's actually flexible, but just for about an hour. So my idea was to really take a mold, bring it directly to this machine, and immediately start to mold this object next to the machine. So these were the first sketches. So sketching is very important for me. We try to be in our office, because I try to be very analog in the design starting phase of the design, and these are just the first ideas. You see on the right the bundle, the maximum size of such a bundle. It's 1 meter times 2 meters 60, which is not that large, but I figured out that this could be enough for one chair. And a chair, again, was, for me, it was very important that to use this material properly. The material, as I mentioned before, was designed for really hardcore outdoor usage. So all year long, since it was used for roofing and facades and so on. So it's frost resistant, it's of course water resistant, so it's lasting for a very long time. And this was actually my idea, to create a modular outdoor furniture out of it, which it's really meant to be very long lasting and standing out for the entire year. So these were the first sketches. You can see it's also, for me, it's very important to think about what we've also discussed before in the workshop, who is going to use it, how it's going to be used, and here you can see the first tests, and this was what I've mentioned before, the things about failure. It didn't work out at all in the beginning. Here you can see how 6 workers in Slovenia tried to attach this material, which you can see is very thin, to a mold, but it's sooner or later, after the third test, we figured out that we had to adapt the shape. So actually the actual design of this furniture is derived from the material's capabilities. So we had to figure out what's the optimal curves of it till it breaks, what's the most, through which radiuses we could get the most stability out of it, and so on. So what I did is I drove to Switzerland, where this furniture is manufactured, and we did this with homemade styrofoam shapes and just tested it. And this also was very important for me to build up in relation to this really unique material. And here you can see that we just laid the material over the shape and it almost draped it, drapes this over perfectly from its own weight. And of course then the computer phase started. We tried even to combine our know-how, our gathered know-how with some digital force visualization models, and and also that's also a part of the designer's office, is to think on how to manufacture this thing, because it's a pretty new shape, it's a new material in this combination. So my job is also to think on how to mold it. So we used a positive and negative mold, and that's also our part. So when I started to design, I always thought, this super technical stuff the companies will do, and I just have to take care about the nice shapes and so on. That's simply not true, because if you don't consider this, this can be the end of a project immediately. So that's engineering and understanding of engineering. It's a big part of my job as well. And these were the first models we did in a production facility in Slovenia, and these are very important for me, because it turned out that it really is stable enough not to fall down immediately. So you can see on the right side, the light thing is the CNC milled shape where we draped it over, and the left one is the unmolded object. So these were the first tests, and since it should be modular, we actually developed 4 different types, so to keep it very simple, which on the other hand enabled a lot of possibilities. So the aim was to keep it more linear for really, imagine spaces in front of museums, universities and so on, or even shopping centers. And the material is available in actually 3 colors, so the cement has 3 different colors without painting it as the own color of the material. And this was actually the first product shot. You can see now in a lot of magazines and so on, because we earned 6 design awards then for this project. And it's manufactured since 2011, really thousands of times now, and it's now even visible in Kosovo. This, for example, is a museum space in Vienna, where it's also in use, so in large scale use. And this image is for me very important, because there you can really see that it works in public space environments or in photo shooting environments as well. Let's go to a completely different project. This was also a rather old project I did, and this was for a company in Belgium called 6 Inch, and they asked me, Rainer, we would like to do a shelving system which is cheap and easy to ship worldwide. I mean, a shelf is always a problem because it's a huge thing, and as you might know, logistics are sometimes the killer for a project because it creates so much, it's very expensive and it's very tricky to handle and so on. So this was the idea, and this was the time where CNC milling came more or less up to create something which, a shelf which is completely flat backed and has just these 3D CNC milled slits, and you put it together, and through adding more weight to the shelf, it even becomes more stable. So this was also around 2011, so start with the older project, and this is, the good thing is both products, 2005 even, so even that product is still in production and has been manufactured really thousands of times till now. And we have, this is a shot from our office where we put all our models and so on. So it's the interesting thing, aspect of this shelf is definitely that you never can bring order into that, which I really like. This is another project which actually came after the shelving thing. It was meant to be, so sometimes, most of the time we do industrial design for serial production, but sometimes we got commissions by museums or exhibitions. So for instance, this was a commission for the Biennale of Interior Design in Kortrijk, that's in Belgium, where they asked me, the curator, that they have a huge space, imagine twice as large as this entire cinema. And he said, yeah, couldn't you develop a furniture which of course shouldn't cost that much. So I contacted one manufacturing company which is good in foam coating, and nowadays is really a good, very close friend of mine, the owner of it. This company is 6-inch, but the foam coating has a limitation. It becomes expensive as soon as you leave the second dimension. So when you mill 3-dimensionally, it's impossible to manufacture really furniture for these two large sizes because it would be too costly. So what I thought is to create complex 3-dimensional shapes, just sliced it into 2-dimensional elements, and by gluing them together you get the results of a really 3-dimensional sculptural object. So we manufactured actually 6 of these 6-meter long, they called Cliffys, and it was such a big success that the people started to ask, can we buy it? And I said, no one will ever ask this question. Who needs a 6-meter long worm in his office or so on? But guess what? Quite a lot of people do. So we brought it into production, and so it's one of my still one of my most successful furnitures, especially in America, since they seem to be that they have more space than in Europe. So we made 6 sizes out of it, and it's still really internationally very successful, and you can get it in different colors. One interesting aspect I completely forgot to mention about it, this thing is soft. Of course, this is not hard, it's not MDF or so on, so it's foam, it's soft coated. So the interesting thing was, and this was also my intention behind this installation, was to create this, very hard, rocky looking style, but it has this surprising effect that as soon as you touch it, it's actually pretty soft. You can jump onto it without injuring yourself. So this was the contradiction between hard shapes and soft in its functionality. This is on the Airbud in Tokyo. They also use it. They have ordered 10 of it, for instance. This is, as far as I know, in Shanghai, in a tech center. They also have plenty of them. And this is in Mumbai, in front of a showroom. This is a hotel in Shanghai. I didn't design the room of it because sometimes maybe it might be a little bit too much, but it's all about the furniture. This is another project. This was a hardcore industrial design project because in Austria there's a very famous company called Austroflamm. And Austroflamm is one of the market leaders worldwide for stoves. And so you might know the stoves, you might not need it that much here in Kosovo, but in Austria you really need this stuff because they have these typical glass windows in the front where you can see the flames, and they're very common. Austria, Germany, Scandinavia, everywhere where it's cold, Canada, of course, North America. So the company asked me to design a stove, and as I always re-ask my clients, I said, okay, basically I'm not that interested to design just the outer hull of it, but I wanted to re-question, re-ask the disadvantages of these very commonly known stoves. And one big disadvantage is, so the stoves, an advantage is that they are nowadays that well engineered that they store the heat for a very long time. So you put one piece of wood in the evening in the stove, start the fire, and 12 to 16 hours later on, it's warm. So that's a big achievement. But the problem of the stove is that it takes pretty long time to heat up. So imagine coming home from work, super freezing cold out there, you put some wood in there, and it takes 2 hours till it becomes warm. That's way too long. So my thing was about reading books about physics and thermodynamics, is how to maximize the convection energy. So convection energy is basically when the air touches the metal of the object and this heats up the air. So this is the way quicker form of heating it up. So this was actually also, the design was totally derived from this idea. So we have these aluminum things which create kind of a protective skin around the stove, because you actually could hack this stove now because it's just has 60 degrees on the outer surface. A normal metal stove, you have to imagine, sometimes gets up to 90 degrees, which no one wants to hack and thing which is 90 degrees hot. So this was also something, because I consider a stove not as a technical machine. It is, yeah, the function is of course primary in this case, but it's also a piece of furniture. It should really integrate itself well in a nice contemporary interior situation. So this was the other task, and the result actually, as you can see, this is the back side of the stove. Here you can hardly see, but here is the tube is going up from the top. So it has a very sculptural appearance, and actually it's pure function. So it really works out well, and you can see a detail out of it. So the function becomes actually the entire design. I didn't wanted to add anything anymore because we really like this, how these fins react in the different lighting situations. This is another project. This is a rather new project, and which was really demanding. It's for an Italian company called Axolite. Axolite is a very well-known company which exists since the 70s and is located in Venice, close to Venice. And Axolite asked me to develop a light for them. Light, I love doing light, but it's you need a lot of know-how and so on. And it really took me years to really become professional in this topic. And there's one general problem with development of LEDs, as you might know. So everyone likes LEDs, I know, but LEDs, and everyone tells you that one LED lasts for 40,000 hours or 60,000 hours, and everyone thinks, wow, that's so great because it lasts forever. But there's one compromise. So if an LED doesn't have an proper cooling, it lasts for 1,000 hours, and it's gone before a conventional light bulb is gone. So it's not everything with LEDs, not the solution for all the problems. So the thermal engineering of a light is very, very important. So it might not sound that sexy in the beginning, but what we did, and like we do with all the projects, is I take these problems, analyze them, and then I see what I can do. So the shape or the design is never, it's never the start of an idea. So all the ideas derive basically out of problems or interest in new directions. And what I did here is to figure out a shape, basically, which has a maximum of surface, so an area of surface. So we thought in a shape made out of die-cast aluminum, which is pretty expensive, so it needs to be really functional in my opinion and not decorative. I don't see designs should never be decorative in the first place, because that's too superficial. So the idea was really to create this shape which has the ability to cool down the inbuilt LED. This is a completely closed shade, basically, by its large surface area. So, and the other thing is that since this die-cast aluminum shade to manufacture this object is very expensive, so you have to invest at least 30,000 euros in the mold for this, then it becomes cheap to manufacture this shade. So the starting investment is pretty high for this company. So what to do with this shade? Just to invent a shade for one light, in my opinion, doesn't make sense, it's not sustainable. So what I thought about is how to use this different, always the same shade. What can you do with it by just twisting them, turning them around, and what typologies you can get out of it. So this, for example, were the first studies, the first drawings of floor lights. But I thought, why not turn them around, hang them from the ceiling, and then also it became the idea to call this project Orchid because it has something very organic in it. And the final thing, these were the first prototypes we had. Actually, here you can see the shades. It's on one hand very technical, on the other hand it's this very playful language, formal language. And this was actually the floor light. So it's a multi-directional floor light which has on the lower section a light for, I imagine myself sitting there reading fancy design magazines, and the rest of the room is enlightened by this upper light and so on. So it creates very interesting room situations. This is the vertical pendant light from the ceiling, which also has this flower-like appearance. And remember, all of these single shades are the same. So it's just about attaching them. We also made an horizontal pendant light out of it. And ceiling light, wall lights, so we have then certainly, suddenly we can get out a lot of different typologies. Here you can see them in action. Here we have the horizontal pendant light, the floor light. In the back you see actually just the single shade attached to the wall, which is the wall uplight. So we created an entire family of this floral looking object, and I think this is very special because sometimes people ask me, Rainer, how do you describe your style? I say, I don't know, I can't tell you. I can't tell you that I like this and that shapes. It's basically derives from problems, as I mentioned before. And in the end, I like objects which also have sculptural qualities. Light, as it is with the stove, is for me an object which should look nice under different lighting situations, even if it's not turned on. So that's very, very important. And light shouldn't only look nice when it's in full function, because what do you do when it's not turned on? So that was also, this is something what's, for me personally, is important. This is a hotel where we used it, so it's already on the market since this year. And we got also a couple of design awards for it, so it was worth the 2.5 years of development. That's also something I've told my students at the workshop, because I thought in the beginning, I don't want to become an architect, because the times from the creative process till the finalized house are that long. But nowadays I see that maybe it wasn't the right decision, because if I'm designing a light from the first sketch till it hits the market at the furniture fair in Milano is 2.5 years, so it's kind of comparable already. And it shows what complexity lies in this object. So it's, but that's also the beauty of my job. This is another light I designed for a company called Modularity in cooperation with Eternit, with the Swiss fiber cement manufacturer. And it was actually funny because this company asked me to design a bollard light. I don't know if you are familiar with bollard lights, but normally bollard lights are light typologies designers don't want to design in the first place, because bollard lights, you might know when you have a parking lot or your private entrance of your house, and you have these tiny little lights on the floor just to light the street, so to see when you park your car. So even on that project, I was asking myself, okay, how can I bring some innovation into that strange typology? And I thought, what would happen, or what happens most to these bollard lights? Of course, when you drive home, it's late, you have been to an opening, or I know it's not allowed, but it can be that you drank 2 beer too much, you pull back with your car, hit the bollard light, it's damaged. So that's a problem with it, that you always crash with your cars into them. So for me it was important to create a shade which is easy to remove and which is not that costly. So the result was actually, here we did this test for the shades. This was also molding examples where we tried to mold this fiber cement material in very simple shapes. So to get the max of stability out of it, but still to remain, to keep this visual lightness. And these were actually the final object. So you can see the black parts are purposely made in black, that it differs from the outer shade, are made in die-cast aluminum. So it inherits the completely LED converter and LED technique. And the outer part, which is actually the easy and visibly attached through these 2 screws, attached shade. So the shade can be broken, no problem. You call the company and order another shape if it's necessary. So this was the idea again, that the design derived from the actually a basic problem. So that, and this I also wanted to show in this case that it's easy to remove. So when you you know, this kind of icons, when you show and screw that visibly, the user understands, okay, I'm allowed to change it also. So that's very interesting how to use these icons in formal languages in design. So here you can see the full size. It's that high, just to remember, it's a bollard light, not a floor lamp. And we of course made a wall light also for outdoor usage, so it's completely waterproof and you can use it as an up light or a down light. This is something completely different. It's also for a Belgian company called 6inch. I've been talking about them before, and they asked me, since we have been realized some quite successful products with them, they asked me, Rainer, we are expanding with our company. We want to have a modular seating system. So seems as an easy task, it isn't, and I also started my analyzing process. And 6inch is a very interesting company because it has a decentralized manufacturing system. So what they have is, the headquarters is in Antwerp in Belgium, where they do the expensive molding parts and plastic parts. They manufacture it there and then they ship it to worldwide. And nowadays 6inch has more than 10 manufacturing plants for cutting foam. So they are good in plastics and cutting foam. So plastics is expensive, so you have to think in a very, you use as less and little plastic as possible. The foam is too expensive to ship, so they have this decentralized manufacturing system. So my idea was to develop a basic pallet system, which is highly efficiently stackable, manufacture it in Belgium, and then ship it on a minimum size worldwide, where then they add these cushions onto it, which are produced locally. So you can see the right side, these were the first ideas of it, how to do it. Again, we did the entire modeling, and here you can see an intersection through this, how to get the maximum out of it. This is basically a rotomolded plastic part, and which you can stack pretty well, actually, and very efficiently. And here also I wanted to show you some, we always build some models, try out the same basically what we did here in the workshop to see how it works, what combinations are possible. And since this is a very highly flexible system, you are supposed to use in offices and so on, with headrest, top rests and so on, it should be highly modular. And here you can see these are the shots you normally don't see. That's a plastic manufacturing plant near of Brussels. And I'm not sure if you're familiar with rotomolding, but rotomolding is basically enclosed low pressure temperature mold. You pour in the plastic granulate, close the mold, heat it up, and then rotate it, open it, and the ready-made thing falls down. So the idea of it, or the result of rotomolding, is in a way limited because it just creates closed volumes. And we wanted to use this technique basically to, in one manufacturing process, to produce 2 pallets out of it. So what we did is we made an enclosed rotomolding form and opened it up, and 2 pallets ready-made fall out. Here you can see also the behavior of plastic is very interesting, since it's super soft in the beginning, but hardens out in the next 2 minutes basically. So this still has for sure a temperature of 60%, so I don't know how they could touch it, or 80 degrees I guess. And the molds are made of CNC milled aluminum, and you can see it also has integrated the connection system of it. And I wanted, regarding the design of it, for me it was very important that it has this kind of trashy rotomolding aesthetics, because what you use rotomolding normally for are these huge tanks of plastic tanks to store water or stuff like this. So they have a certain aesthetic to make them as stable as possible by a minimum material usage, since we all know that plastic, we shouldn't use that much plastic, so use it very efficiently. And here you can see the objects with this attached, in this case, coated cushions onto it, or this detail. So it has a very technical approach. It's actually a combination of 2-dimensional curves, which in combination create this rather complex and interesting surface which behaves differently under different lighting situations. And yeah, this was at the fair in, so we have basically 2 shapes, 2 of these pallets. You can attach them to different combinations. It's my Japanese colleague checking if I did a good job. And here this, yeah, elements again. And these are some renderings, but this is how we use them. So we have different topics. The tops are changeable for different situations, in furniture situations and so on. And it's also very successful on the market actually, which makes the designer happy as well. This we already had. I'm sorry for that, but this was not going to here. Yeah, this was also a project I want to show you. It's a flower container. Why do I show you a design of a flower container? Because it's also, I think, visualizes my approach to design. So the company at the NIT, since I have now done quite a couple of designs for them, asked me again to design a flower container. Flower container, why? Because as I have mentioned before, the material is perfect for auto usage, very durable, frost resistant and so on. So I visited the company in Switzerland and said, okay, I'm going to do a flower container, but show me your collection. So at the NIT I have been working with very well-known designers as Alfredo Heberli, Willy Gulf in the 50s, 60s and so on, already started, so they have huge collections of already made flower containers. So I think they have about 50 different models, every shape, every design from every design area. So I said, okay, what's the need of doing another flower container? And during my visit there, I recognized that the maximum height of these flower containers is actually 70 centimeters and not higher. And in my opinion, it's very important, especially for a flower pot. Imagine a hotel entrance, a flower pot with 70 centimeters low, it's too low. And I asked them, what's the problem? What's the reason why you have never built one which is 1 meter high? And they said it's the limitation of the human body. So since these flower containers are manufactured in a semi-industrialized, very unique manufacturing plant, so there are 100 people there, and they are very tall and they have very long arms, and I know now why, because they have to reach with the arms to the bottom of this container. So the limitation of the human body is actually the limitation of their collection, and it's their limitation on the market. So of course this made me really interested into this topic, because it's such a bizarre fact that I thought, okay, let's think in that. And I developed the idea of you have to imagine this fiber cement material is attached in layers into a mold by a person. And my idea was to grow it like a palm tree. So in palm trees, sometimes some certain forms of palm trees consisting out of different layers of, so our manufacturing process actually was directly derived from that. And here you can see the molds of it. So what we did is basically we attached two, we made a stackable mold to make them higher. You see the happy manufacturer, and here you see the final flower containers, which have this palm tree appearance, but it was not for the sake of looking like a palm tree, but actually it visualizes the manufacturing process. So that's important, and that's also important, I think, to see the behind the scene, that it's not about the style, but the style derived from a problem, which we solved successfully. This is completely another project. And also I would consider it as a hardcore industrial design project, because there's this Swiss company Rado, and Rado is very well known in it's a watch company, manufacturing watches since the 50s basically, and they asked me to design a man's wrist watch. And Rado is known for its very special usage of materials. So they are very good in high-tech ceramics. So what they do is they developed a certain kind of ceramic material which is it's optimal for the usage in a watch. I have it here, by the way. And this material, because it's good because it's super scratch resistant, it's light, it's super stable, and it's very long lasting. So compared to the hardest steel, ceramic is the better material in certain situations. The other thing was, when someone is asking me about the watch, again, now you know me, I ask, okay, how can I bring something new into it? Because I don't want to design the 1,000,001 watch, so I was asking myself, okay, what can Rainer do in the watch business? So what I did was re-questioning our general usage nowadays of a watch, because all of you have mobile phones in the hand. If you want to know the time, you pick up your mobile phone. So the watch itself it changed, the usage of a watch changed. So I thought, and especially since they asked me as an industrial designer, not a graphic designer, I thought, first of all, I don't want to, sorry, this was, you have to tell me when it's a problem with the time. I asked myself, what can I do? So watch design, it's about the casing out, you have a shell, but it's a lot about the graphic design of the dial plate. And I'm not a graphic designer, so what I was interested in was more to visual time in a new way. So in a very minimalistic, but maybe a very poetic way. And here you see the first sketches. And I thought, how many times per day you look at your mobile phone and your watch and actually never look to the sky. Could be because you are in an office room or because you are simply not interested, but what we forget about is the sun is defining basically our time system, and we shouldn't simply not forget about it. So my idea was, and here you see a close-up shot of the finished watch, is to give the watch and depths. So I really took out the max over the clockwork and saw that there's actually quite a lot of space. And then I attached this circle on the bottom side of the glass, so it's metallic steamed onto it, so it was a very complex procedure. And when you look at it, you can see it here, even if it's in studio situation, it draws a certain kind of shadow. So this watch looks different if I look at it now, because you hardly can see the depths, but when you see it in bright sunlight, it really unfolds actually its three-dimensionality. And this was very important for me. So there are no digits, there are no 12, 3, 6 and 9s. I think everyone knows how to read the watch, so I thought, why should we print it on them? And what I integrated was this three-dimensional curved surface as a dial plate, because I was asking myself which three-dimensional surface shows best different lighting situations. And this is kind of inspired by landscapes and so on, where when the bright sunlight hits a structure and it draws nice shadows, you get a really good feeling and perception of three-dimensionality. Here you see the close-ups of it, so it's entirely made, the bracelet and the casing everything is ceramic, so it's really this durable material. It's an automatic watch. And of course, I wanted to show that the mechanisms behind it as well. So I took this asymmetrical part from the front side and reflected it in a different way on the back side. You can see through this glass window the actual weight of the automatic watch, which is basically the heart of an automatic watch, because this is what makes it work. And if you look closely, of course, the name of the design is also on it. Yes, and it's on the market since last year, and very successfully, because it was a limited edition actually from 1,000 pieces, but they already regretted this decision because it's almost sold out. So if anyone is interested, call immediately. There might be some pieces left of it. This is another project which was very challenging. This is, I'll hurry up a little bit, but just flip through it because this is very different from all the other stuff. There's a company in Austria called Visa, and this is a marble manufacturer, and they are one of the largest ones in mid-Europe. So what they do is they cut, buy and sell marble, and they have a very high-end milling equipment and CNC robots and so on, but they basically don't know what to do with it. So what they asked me, Rainer, we have this machinery, we have the equipment, we'll book the flight for you, we'll go to Carrara, to the quarries, and you have to, we want you that you look at stones and get into this topic of marble working. And this was actually one of the quarries in where Michelangelo also took his stuff from David, from his sculptures and so on, and I was asking myself, okay, what I'm going to do with it. It's not about to create another, there are a lot of milled marble furnitures already on the market, so I was thinking about the idea of visualizing the statics of marble. So what we did is, by trying, here's some milling tests, this was a base for a table, this was the shelving actually. So this has kind of a rhythm, it has a structure, but basically it's visualized the maximum possible of this material. So we analyzed how thin we could go on the ends. So we are 7 millimeters thin, this is a shelf and this height approximately. And since an employee of mine is a very good engineer, we developed a statistical system and tried to limit to carve out as much as possible out of this precious material and just visualize actually the basic statics situation. So it's made out of one block, as you can see. It's not very cheap. I don't own one yet, but I'm not sure if I ever will own one because it's very expensive actually. But you won't believe it, there are people on the planet who can afford this stuff. We also made some wall panels out of it and a 3-meter long dining table. And yeah, I think basically I'm done.